We're back. We're at the end of Unit 9. Here we are. We're going to review those skills that we've examined through Unit 9, the polar coordinate system. Let's start here by looking at plotting coordinates and polar curves. So when plotting coordinates, we want to recall that we look at the angle measure prior to looking at the radius. So 150 degrees. With this polar coordinate system, because we have some extra degrees here, I'm actually cross out with my little marker the ones that we don't use. So this, what would be pi over 12 maybe? I don't know. So we just disregard these. Make my little marks that will help me remember that. So 150 degrees, that would take us to right here. This is 150 degrees. And then -4, so that takes the negative radius takes us through the other side, which would be, this is 330. Okay, and that would take us to 1, 2, 3, 4, and that is R. All right. So then from there, let's see, -60, -2, so -60 going in the opposite direction take us to this point, -60 degrees, and then -2 that takes us through the other side, which is 120. So 1, 2. That's coordinate S. And then let's see. Okay, we're back to radians. So 7 pi over 6. That's one whole pi. So 6 over 6 is here. So 7 over 6 would be here. 7 pi over 6. Positive radius. So we go in that direction. 1, 2, 3, and that coordinate is T. All right. And then U, 2/3 pi. So 2/3 pi is 120. And we have to put that here to 2/3 pi. Okay. And then 6, so it goes in that direction. 1, 2, 3, 4, 5, 6. And that is coordinate U. And then 45 degrees, that's rather straightforward, quadrant 1. And then -1. That takes us to the 225 line, and then -1, so just 1 on this side. And that is coordinate V. So looking at the angle measure, remembering that a negative radius takes us through the pole, I believe I said origin, takes us through the pole to the other side. So let's use this to actually plot. So let's plot this curve. Knowing your unit circle, could help you, but really we're going to need to know the decimal value for these. So you've gone through how to get the decimal value. We place 0 in. Now, some confusion, there is a 3 theta here. So before I take the cosine of my angle, I have to multiply the theta by 3. So here's what I mean. So 3 times 0 is 0. So cosine of 0 is 1. So we get 2 here. Next, 3 times pi over 6 is pi over 2. So cosine of pi over 2 is 0. So we get 0. And then cosine of 3, so 3 times pi over 4 is 3 pi over 4. So cosine of 3 pi over 4 is -√2 over 2. We multiply that by 2, and we get just -√2. Which I'm going to start giving decimal values. We get -1.4. Okay? So then 3 times pi over 3, well, that's pi. Cosine of pi is -1, so we get -2 here. And then it just kind of starts repeating. So multiply your angle measure before taking the cosine. You could easily place this into the calculator. Some of you probably would. So I'm going to go through this real quick. I'm going to speed up the video, just get through this rather fast, and then we'll graph it. So let's go. Okay, so that really didn't take long at all. Well, it just doesn't help that I also had the values already calculated. So this is what we have here. There's a cycle that we go through. So let's plot these. So 0, 2. Okay. 0, 0. Okay. Pi over 4. And then -1.4. So negative 1 points to negative 1 and roughly a half. Okay? And then negative at pi over 3, we're at negative 2. That's negative. There we go. So disregard that, guys. So then at, let's see, I'm just going to go through this. At pi over 2, we're at 0. Okay, so right now we have this kind of appearance. That. And then I'm going to just go through this and plot the rest. All right? Okay. Now, once we pass 2 pi, we notice that we have really a cycle where we start overlapping our current graph. We start just going over it again. The reason being is because knowing symmetry, and we'll look at that later on, this curve being only in terms of cosine, this curve is symmetric to the polar axis. So once I go from 0 to pi, I can think of just reflecting the rest over, which, what I currently have, that would be taking me onto existing points. So notice here, at 4 pi over 3, that's positive 2. Well, that was the same as pi over 3 at negative 2. Okay, so they kind of connected. And then at 3 pi over 2, that's 0. That's, yeah. And then at 5 pi over 3, which would be over here, it's negative 2, which was equivalent to the 2 pi over 3 at positive 2. So at 5 pi over 3, we're at negative 2, so it goes over here to an existing point. So I want to say that we can't depend on this, because if I had a 5 theta or 6 theta or 2 theta, that may not happen, where it's repetitive and we just do half of the table and then stop. So just still go through. If you notice a repetition, go through to make sure that in fact it's just overlapping existing points and not adding on. Okay, so we have here a 3-petal rose curve. Let's look at the next curve. So we have, let's see, plot the curve 1 minus 6 sine theta. Okay, so nothing, we don't multiply our angle measures, so it's just sine of that angle measure. So sine of 0 is 0, so 1 minus 0 is 1. Pi over 6 is 1/2, so half of 6 is 3, so 1 minus 3 is negative 2. And then starting to use the calculator possibly. So we are back in radian, so we're going to change my mode to radian. Okay, so we have in this, we have 1 minus 6. I'm just showing you what it would look like. Sine of so it's not 3 times theta, it's just theta. So pi divided by 4. We get negative 3.2. Okay, I'll put 2.24. All right, now we just continue this the whole way through. So I'm going to go and do that for you. I encourage you to take the time, you yourself, to pause and fill in your table and check back to see what you get. All right. All right, so let's plot these. So we have at 0, we have 1. At pi over 6, we have negative 2. Okay, and then let's see, at pi over 4, we have negative 3.24. So 1, 2, 3, and roughly a quarter. Okay, at pi over 3, we have, let's say that'll be 4 pi over 3. I'm doing this because we have a negative radius. Negative 4.2. Okay, and then at pi over 2, we have 5. Okay, and we start seeing some repetition. So at 2 pi over 3, so that'd be here, we would have, again, negative 4.2, so right here. And then at 3 pi over 4, we have negative 3.2, so that would be, well, here. I'm looking at the other side and just kind of matching it up, really. And then we have negative 2 for 5 pi over 6, so negative 5 pi over 6, but negative 2. Okay, and then at pi we have positive 1. So pi, positive 1, that's towards pi. Okay, so right now we have this portion of our curve. Okay, and moving on, so 7 pi over 6, we're at positive 4. So I'm going to switch colors here just so we can see what's happening now. So 7 pi over 6, we're at positive 4, so I go towards positive 4. So 1, 2, 3, 4. At 5 pi over 4, at 5.24, so I go towards that. So 1, 2, 3, 4, 5, and then 0.24. Okay, 4 pi over 3, at 6.20, so I go towards this value. 1, 2, 3, 4, 5, 6. A little bit off of it. And then at 3 pi over 2, I'm at 7. Now this only goes out to 6, so I can roughly estimate to be right here. And then I just start seeing some symmetry. And at 2 pi, we're back at 1. So we get there we go. All right, so kind of a nice curve, isn't it? Looks like a pendant or I don't know, some sort of logo. So we have graphing, plotting points, knowing how to work with the equation, knowing how you use the calculator. So we're going to move on here and look at converting coordinates equations from polar to rectangular to rectangular to polar. All right. Okay, so we're looking at converting in this first couple examples, converting from rectangular to polar. So 3 comma negative 8, converting that to polar. So we have to use these two conversion equations: x squared plus y squared equals r squared, and then arctangent of y divided by x will equal r theta. So if we think, okay, 3 squared plus negative 8 squared, it's going to equal r squared. Well, that comes out to be 73. So we would have the square root of 73 is our radius. And then the arctangent. So in the skills review, I go over what exactly we're doing here. So when you use the arctangent of negative 8 divided by 3, we get negative 69.444 degrees, and that is within our, actually not within, that is in the same quadrant as our coordinate. So we have the two pieces. So our polar coordinate would be the square root of 73, comma, negative 69.444 degrees. Okay, so doing the same thing with number 5, x squared plus y squared equals r squared, and then arctangent of y divided by x. Now in this problem, you should get the radius to be the square root of 26. Now when you apply the arctangent of 1 over negative 5, what we actually get from this, let's see, so we get, so arctangent, we are in degree, that's good, of 1 divided by negative 5, we find that we get negative 11.3099. Now that is not in quadrant 2, as the coordinate is. So we have to go through and we have to add to this. I'm saying add, but really we're subtracting the angle measure from 180, but it's already negative. So we want to add 180 in this case. That will take us to quadrant 2. So our theta is 168.6901. So we have our two pieces, making the coordinate square root of 26, comma, 168.6901 degrees. All right, just knowing the conversion equations and utilizing them. All right, so now converting equations from rectangular to polar. Looking at x equals 4. So the conversion equations we're using here are going to be x equals r cosine theta, y equals r sine theta. So that would be what we were using for this. So I see x. I want to replace x with r cosine of theta. Now the goal is to have r equals an expression only in terms of theta. So I have r. I want to isolate the r, so we can do that by dividing by cosine. So we have r equals 4 divided by cosine of theta, which is equivalent to 4 secant theta, because 1 over cosine is in fact secant. So either expression would be acceptable. So looking at the next, 2x minus 5y equals 11. So I see an x, so I'm going to replace the x with r cosine. I see a y, so I'm going to replace the y with r sine, equals 11. So both term has an r. R is 2 cosine theta minus 5 sine theta. Okay. Now we want to isolate r. That's be rather easy. We just divide by this group, giving us an equation in polar form of 11 divided by 2 cosine theta minus 5 sine theta. All right. So it might be good for us to know that this form of a polar curve turns out to be a linear function. Okay, that might be beneficial when we go from polar back to rectangular. It might be beneficial to know that. So then looking at the last, so the last one, we want to kind of expand this x minus 3 quantity squared. So in actually expanding that, we get, it's x minus 3 times x minus 3. We know that. So that's going to be x squared minus 6x plus 9, and then plus y squared equals 9. All right. So we have, I see a 9 on the left and right side, so they're going to cancel. I see an x squared and y squared, so that's going to come down to just r squared. I guess I should have written that down too. Over here, x squared plus y squared equals r squared. That's one of our conversion equations we already saw up here. So it's r squared, and that's the x, which I'm going to replace with r cosine of theta. And then subtract 9, subtract from the other side, it's going to be 0. Fair enough. I'm not going to factor an r out because I'm going to add this 6r cosine to the right. So we have positive 6r cosine of theta. Now, yes, I have an r on the right side, and that's an issue. Well, we can divide both sides by r. And in doing so, we get r equals 6 cosine of theta. R equals an expression in terms of theta, and we're done. So we have converting from rectangular to polar, and we use mainly the x equals r cosine, y equals r sine. And when we see an x squared and y squared, we can substitute in r squared for that. So moving on now, and I believe what's next is converting from polar to rectangular, and I am correct in saying that, so let's see what we can do here. So going from polar to rectangular, we know that our x coordinate is going to equal the radius times cosine of theta, and that our y coordinate is going to equal r times the sine of theta. That's it. So when we go through this, let's see, that would mean that our x is equal to -9 times cosine of 150, all right, and our y is equal to -9 times the sine of 150, okay. So we can use the calculator, we can use our knowledge of the unit circle. So that's going to come out to equal, let's see, -9. We are in degree, cosine of 150. We get 7.79. And I know sine of 150 is, well, 1/2, so we get 1/2 of -9 or -4.5. And with converting to rectangular, we will not have to decide what quadrant we're in because the angle helps us go to the quadrant that we are in. So number 10 is the same exact thing. X equals r cosine, y equals r sine. So when you do that, you should get a coordinate of, just so you can check your work, 2.46, 1.72, just so you can check your work there. Again, 3 times cosine of 34, 3 times sine of 34. Sorry, not 34, 35. All right, moving on. So converting polar equations to rectangular equations. So in this, if I see an r cosine, I can replace it with x. If I see an r sine, I can replace it with y. If I see an r squared, I can replace it with x squared and y squared. Okay? Now let's look at number 11. So this form looks familiar. We just looked at it a couple minutes ago. So to deal with this, I'm going to multiply both sides, and I encourage you as well to think of this to remove the whole fraction from the problem. So we're going to multiply both sides by the denominator, okay? So that's 2 cosine theta minus sine theta. That would give us, I'm going to go ahead and distribute the r in, so r times the first term, r times the second term. That would give us 2r cosine theta minus r sine theta. So the purpose of multiplying both sides is that this will cancel, and we're giving us just 5. Perfect. We have an r cosine, there's our x. We have an r sine, just an r sine, so that's only y equals 5. That is a rectangular equation that we know is a linear function. Okay, let's look at number 12. So number 12, we have r equals 2 sine theta minus 12 cosine theta. I don't have an r sine or r cosine. I don't have a fraction where I could multiply both sides by that denominator. I don't have an r squared. So the technique here is to actually multiply by something so that something will substitute in. And what we're going to do here is we're going to multiply both sides by r. So we get r squared, which is good. We get 2r sine theta and 12r cosine theta, which is perfect. Okay? That would mean that we get, well, I'm going to go ahead and substitute our terms in. We get x squared plus y squared. And we get 2y minus 12x. Okay? Now we are going to, right now, we're now into completing the square. So you move everything on one side, that gives us x squared plus 12x, and then y squared minus 2y equals 0. So I'm going to come up top to complete the square. So completing the square, let's think. So in the skills review, we go over this. If you have not yet, you might want to pause and go and look at that real quick. So we have x squared plus 12x. Let's see. So that would be 6. 6 squared is 36. Okay, and then we have y squared minus 2y, so it's -1. -1 squared is +1. And since I substituted in a 36 and a 1, I have to add that 36 and 1 to the right. Okay, so that would make it, okay, we condense. We would have, let's see, x plus 6 quantity squared. Y minus 1 quantity squared. Again, I go over how to do this in the skills review. 0 plus 1 plus 36, that's 37. And then we have our circle equation. So circle centered at -6, +1, with radius of square root of 37. And it's better for us to write it just as square root of 37 and not provide a decimal, because this is the exact. Okay, and we're not asked to graph it. We're not asked to do anything else with it. Just identify. Looking at the next. So r equals 4. Not 4 cosine, not 4 sine. So we're not going to have an r cosine or an r sine to substitute. So in this, in the previous problem, I multiplied both sides by r to get an r squared. But if I multiply both sides by r, I get 4r on the right, and that we'll get stuck with that. So in this, we are going to square both sides. I'm going to write that, square both sides, giving us r squared and then 16. Okay, well, isn't r squared equal to something? Yes, x squared plus y squared. Nice, and we're done. So circle centered at 0, 0, with radius of 4. So maybe, just maybe, if you have r equals a constant, you can say automatically that it's a circle centered at 0, 0 with that radius. So if I were to graph this on a polar coordinate plane, we would get a circle centered at 0, 0 with a radius of 4. So if I had r equals 10, I would have a circle centered at 0, 0 with a radius of 10. So that's converting coordinates and equations from polar to rectangular and the other direction. Moving on. So we're looking now at ways of describing a polar curve. So the first way we're seeing here is symmetry. So I have two problems where we can look at the symmetry of a curve. There are 3 tests we have to apply: polar, the line pi over 2, and the pole. So I'm going to write this. So the polar, that's where we substitute in theta with negative theta. For the line pi over 2, that's where we substitute in theta with pi minus theta. And for the pole, that's where we substitute in theta with pi plus theta. Okay, so I'll put a link here right now, taking you back to that initial lesson where we look at symmetry. But let's look at these 2 examples. So let's test the polar axis. Remember, if something fails this test, that does not mean that it does not have that symmetry. It's just that from the test we cannot conclude that in fact it does have symmetry. So it might still when we graph it, but the test doesn't give us the test itself, when it's not working, isn't a false statement, meaning it doesn't say no, it's not symmetric, it just says uncertain. Okay, so yes or uncertain here. So we substitute in with theta with negative theta, so r equals 2 plus 4 cosine of negative theta. We're going to simplify this, trying to get back to our original. Well, we know cosine of negative theta, since cosine is an even function, cosine of negative theta is the same as cosine of theta. So we went back immediately to the original function. That is good. It is symmetric to the polar axis. So then testing to the line pi over 2. So testing to this line of pi over 2. So we have r equals, let's see, 2 plus 4 cosine of pi minus theta. This is a perfect example where we're going to have to use the sum, actually a cosine difference identity, which we talked about in the skills review. So let's see, we get 2 plus 4, okay, cosine, minus sine, okay, trying to leave space over here, and that's simplified. So we get 2 plus 4, okay, that's negative 1, so negative cosine, and the second term goes to 0, all right, so we get 2 minus 4 cosine of theta, and that is not the same as the original, so this test is uncertain. Okay, we don't know if it's symmetric to the line pi over 2. It might be, it might not be. So looking at the pole now. So the pole is where we substitute in r equals, so we have, is where we substitute in theta with pi plus theta. Now we have cosine sum identity. So cosine sum identity would tell us, all right, so we got 2 plus 4, let's see, cosine pi, oh my goodness, up here, guys, cosine difference. If I'm subtracting, that should be addition, but it didn't matter because it turned to 0. Just realized that. So cosine of, back to here, cosine of theta, it's addition, so we have subtraction, sine of pi, sine of theta. All right, again, we get 2 plus 4, -1, and then cosine. Sine of pi is 0, giving us 2 plus 4, plus 4, minus 4 cosine of theta. So not equivalent to the original, therefore our test, we cannot say for sure whether there's symmetry along the pole. So that curve, only symmetric along the polar axis. So looking at the next, 5 sine 6 theta. This is a rose curve, so there's a lot of symmetry here in the graph, but let's see what these tests show. So let's test the polar axis first. This is often the quickest one. So r equals 5 sine of, we'll say -6 theta. Okay. One thing we know about sine is it's odd, meaning sine of negative theta, the negative pops out front. So this is equivalent to -5 sine of 6 theta. The negative pops out front. That's not equivalent to the original, so we cannot say whether or not it is symmetric to the polar axis. So now, let me kind of separate this. So now let's look at the line pi over 2. So with this, I'm going to kind of skip some steps here. I'm going to skip the sum difference identity for these. You can pause and try it out yourself. So we get r equals 5 sine of 6, let's see, pi minus theta, which will turn to 6 pi minus 6 theta. And we get, when you apply the difference identity for sine, you get -5 sine of 6 theta, which is not equivalent. What's interesting is when you go to plot this curve, it is symmetric along this line. If you look at the curve, it is symmetric along this line, but according to this test, it is not. Okay? So that's why these tests can say yes, but when it doesn't work, it doesn't say no. And then, if you want the pole, that would be r equals 5 sine of 6 pi plus theta. So again, I'm not going to go through this. You can stop and pause and do it yourself. But you get r equals +5 sine of 6 theta. There we go. It worked. So we can say for a fact from this test that it is symmetric to the pole. All right, so that's symmetry, guys. Knowing the 3 tests and working with that. So remembering how you can remember the tests is think of a quadrant, a point in the first quadrant would go. So if I'm doing the polar axis, an angle in the first quadrant would go to the 4th quadrant, so that's -theta. An angle in the first quadrant going over this line, pi minus theta will take me to the 2nd quadrant, pi plus theta will take us to the 3rd quadrant. So there are ways you can remember the tests. Ending with this. So going along the lines of maximum R value, in this, how we test this whole concept is, say, when sine theta is 1, R will equal, well, think of it, when sine of theta is 1, this will equal 8. When sine of theta is -1, R will equal -4. So this does not say what the minimum value is. I believe I mistakenly had said that at one point. This does not say what the minimum value is. This only tells us what the maximum value will be. Okay? Now, looking at this, we have, let's see, we have max value, R value of 8. Now we want to find the theta and the angle measure that yields this value. So what we do here is we set our equation equal to 8 equals 2 plus 6 sine theta. Subtract 2, divide by 6, we get, let's see, positive 1. And taking the arc sine of both sides, we get theta to be. I'm skipping some steps because, again, we went over that in the skills review. So arc sine of 1, that's going to be pi over 2. There is just theta, so I don't have to make a list. So our coordinate is pi 8, comma, pi over 2. All right? So looking at our cosine of 6 theta. So with this, the whole same thing. When cosine of, we'll say, 6 theta equals 1, well, r is going to equal positive 8. When cosine of 6 theta equals negative 1, it's going to equal negative 8. Okay, now with rose curves, because that's what we have, with rose curves, if we have an even multiple of theta, you have to set your equation equal to both the positive and negative max value. So we would say, okay, we have positive 8, negative 8, and it's an even multiple. So I have 8 equals 8 cosine of 6 theta. And then I'm going to have negative 8 equals 8 cosine of 6 theta. All right, so we divide by 8, we get 1 equals cosine of 6 theta. Divide by 8, we get negative 1 equals cosine of 6 theta. This is how we're going to get, if you remember, 6 theta, that means we're going to have 12 petals. So doing this for both, that's how we're going to get the 12. We're going to get 6 and 6, totaling to 12. So cosine is 1 at, let's see, cosine is 1 at 0, 2 pi, 4 pi, 6 pi, 8 pi, let's see, 10 pi, and say 12 pi. All right, and then cosine is negative 1 at, let's see, that's going to be pi, 3 pi, 5 pi, 7 pi, okay, 9 pi, and we'll just go one more and we'll say 11 pi. All right, so in this is still 6 theta, so we do have to divide by 6, guys, giving us the lists of, I don't put the lists all together, okay? So we get theta will equal, well, 0, okay? Pi over 6 from down below. 2 over 6, so it's pi over 3. Okay, we get pi over 2 from down below. I'm doing both lists at the same time. And then we get 2 pi over 3 when this simplifies. And we get 5 pi over 6. Okay, we get pi. We're going to get 7 pi over 6. We're going to get 8 pi over 6 or 4 pi over 3. We're going to get 3 pi over 2. My goodness, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 2 more. And then we have, after 3 pi over 2, we have 10 pi over 6, which is 5 pi over 3. And we have 11 pi over 6. Now the 12 pi over 6, that's 2 pi, so we stop there. So this is our list of theta values. Now this is 12 theta values for 12 petals. Okay, a lot of breath out of that one, after that one. Last one with this review. R equals -2 sine of 5 theta. So with this, we do the kind of same thing. When sine of 5 theta is +1, R is going to equal -2. When sine of 5 theta equals -1, R equals, +2. Now, in this, since we have an odd, how do I put this? An odd multiple, okay? We set the equation equal to the positive maximum value. Here we did to both. So we're gonna set the equation. This might seem odd to you, like we're not gonna set it equal to -2, since that's the first radius value we got. We're gonna set it equal to the positive radius value. So we set 2 equals -2 sine of 5 theta, which means -1 equals sine of 5 theta, which means that 5 theta, because sine's -1, at 3 pi over 2, 4, 5, 6, 7 pi over 2 8, 9, 10, 11 pi over 2, 12, 13, 14, 15 pi over 2. Okay, and then going one more, 16, 17, 18, 19 pi over 2. I'm trying to think of when we'll reach 2 pi. So now we divide everything by 5. In doing so, we get 3 pi over 10. We get 7 pi over 10. We get 11 pi over 10. We get 15 pi over 10, which simplifies to 3 pi over 2. So now we're getting close to the end because we're in the fourth quadrant. And then 19 pi over 10, which is 1 away from 20 pi over 10, which is 2 pi. So we're good. And also I know I'm done because I have 5 pedals. 1, 2, 3, 4, 5 angle measures. Okay, so max, right up here, max R value of positive 2. Here, max R value of 8. So, we have this, there's really a lot here, but a lot of it kind of overlaps. So I wish you the best of luck, guys, as you continue to review here, prepare for this unit test. And I'll see you in the next unit where we get into calculus concepts, limits, and area under curves. So good luck again on your test, and I'll see you in the next lesson.